Okay, this tutorial I'm going to quickly talk you through the suitability of using scattergraphs as a method of presenting data. Now, the first thing you need to be aware of is that the use of scattergraphs is only employed where you are interested in seeing if two variables are connected in some way. And what I mean by that is have some kind of relationship. So as one variable changes, you suspect it might cause the other to change. So for example, in the example on the screen, you can see that as you move down the course of a river, starting at the source at 0 meters and progressively move further down the river to your 600 meters distance downstream, the average water depth is increasing, as we can see that those x's are getting higher. So for example, at about 530 meters downstream, we can see we have the deepest part of the river at 0.25 meters. Likewise, at the earliest point on this river, at about 90 meters downstream, we have the shallowest point at about 0.02 meters of depth. So that's the first reason to do it. When you think there may be a relationship between two variables, you can plot them. The next thing to do is to determine the independent variable and the dependent. And that is where one of which variable is influencing the other. Well, in this case, the distance downstream is clearly the x variable, and it is what is influencing the depth of the water. Because obviously, as you move further down a river, there's more water coming in from the surrounding drainage basin, causing the river to have more water in it, which is why the depth of the river is increasing. Or certainly that's as the theory goes. Great thing about scattergraphs is once you suspect, you are able to then plot your data onto a graph like this. And the first thing it will show you is whether you have a relationship and whether that relationship is positive or negative. So I just scroll down a little bit here. You can see, for example, here we have a positive relationship or positive correlation, to use the correct language, shown by this positive gradient. Talk more about the line of best fit in a second. Second thing you've got a negative relationship between your data. And if you have your scatters like this, then that would suggest no relationship. Now, let's go back to the main scatter I was looking at. Once you've scattered your data, you can add what is known as a line of best fit. Now, that is actually a calculated line using mathematics. And there is a statistical process called linear regression, which will help you determine where the intercept point on the y-axis is. And then as long as you can find out one other intercept point, you can then connect those two, creating your line of best fit. Once you've created your line of best fit, it will show you the gradient. And that will just then indicate just how strong that relationship is. You're able to then visually determine the strength of the relationship by the clustering of x's near the line of best fit. And in this example, you can see almost all of the points are clustered very close to the line of best fit, suggesting a very strong relationship. Indeed, we only have this one here, which is actually lower than this one, even though it's further downstream. So this plot should, in theory, be up here, but it's not. That brings me to another key reason or strength of using scattergraphs, is they help you to visually identify what we might call anomalies, or these are locations or sites where the scatter is not near the line of best fit, and therefore the data point you're looking at is doing something other than you expect. So if you had a little x down here, for example, or up here, that would be a significant anomaly. That would be a data point behaving very differently from all the others. And what that then allows you to do as a geographer is investigate those particular points to try to find out why there is indeed such a high degree of variance at that site compared to what you would have expected. Another reason for doing scattergraphs is it establishes the baseline for then going on and conducting a further statistical test. And depending on how you've gathered your data, you may have to gather, you could conduct a Spearman rank, especially if you have pre-ranked data like locations down a river. And that would then give you a statistically significant result to tell you whether a relationship does indeed exist and whether it is positive or negative. And if your data is organized like this, where you've actually got the actual distance and the actual water depth, you could indeed go one step further and do a Pearson's product moment correlation coefficient, also known as the Pearson's test, which would do the same as the Spearman. It would allow you to test the degree of certainty. So what you can also do here is have a quick read through these key points and some of the limitations and strengths which I've already talked about.